Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. Uh,
Hello, good afternoon, Doctor.
Afternoon. Okay, so before we start, I would like to remind all of you. So for those of you, make sure that you are in the right tutorial group because I have received complaints that one of the lecturer said that her tutorial class, there's no student in her tutorial class. Okay, so if you are not supposed to be here, please join your the correct tutorial group. Okay. All right. So well, before I forget, let me to start the recording. All right. So as usual, we are going to be doing the tutorial together. So you're going to be sharing your answer here in the Google Drive. The link is in the chat. And please remember to sign your attendance as well on Spectrum. Password is in the chat as well. Okay, so today we're going to be looking at tutorial 2. So what we have looked this week is that we look at how we can analyze the running time complexity for a recurrence algorithm. Right? If let's say your program your program have a recursive call, so how are you going to analyze the running time complexity for those kind of program? Okay, so just a recap. What are the methods that you can use to do the analysis of recurrence algorithm? Class, how many methods?
Three methods.
Three. Okay, so name them.
Back substitution, recursive 3, master methods.
Master method. Okay, so we learned that three methods to do the to find what is the runtime complexity for a recursive program. Okay, so today we're going to be looking at some question regarding those meaning in a sense applying those methods. Okay, so let's try and look at the first one. So the first one is using the substitution method. Okay, for this recurrence relation, n squared plus Tn minus 1, where n is more than 1. And here it's a little bit different because I think in our lecture we take the we always take T1, okay? Because as I mentioned, if you notice, I did mention when we do the recurrence relation, normally we say that we always try to see, because it's constant, okay, 0 or 1, it's still a constant, okay, it can be A, it can be any constant value. So it is always like easier to just like put it as 1. But in this case, we put it as 0. And the n can be either 0 or 1. So since n is more than 1, so we can say that it is stopping at 1. Okay, so what is the, so can I have somebody share their answer here? And then we can see whether like whether you have a different question, a different answer, and see where we can if there's any error in it. Can someone share? Last, please go into this Google file, Google Drive file, because I'm supposed to have how many of you here in the Teams? I have I have I have 30. But inside here, I only have like not even 20. So where are the rest of you? So please join, type in, chat inside here, and then we can discuss. Okay. So one of your friend have shared their answer here. Okay. So let's go through this together and see whether we can whether you have the same answer or different answer, and so on and so forth. Okay. All right. So let's see. Okay. So we have Tn equals to n squared Tn minus 1. Okay, where n is more than 1. Okay, so this will be our first equation. All right. So the next step is to find what is Tn minus 1. So Tn minus 1 is n minus 1 squared plus Tn minus 1 minus 1, which equals to Tn minus 2. So this one we call it as the second equation. So the next one, we try to find out what is Tn minus 2. We try to guess what is the terms for Tn minus 2. Okay, Tn minus 2 squared, Tn minus 2 minus 1, where we got finally Tn minus 3. Okay, so we're going to plug in 2 into 1. So we're going to put this equation into here. All right, so Tn n squared Tn minus 2. Okay, so we call it as equation number 4. And then we're going to plug in 3 into 4. Okay, we are going to plug in the Tn minus 2 here. So we get n squared, n minus 1 squared, n minus 2 squared, plus Tn minus 3. Okay, so we know that this is going to run some k times. So we can say that, so the final term will be Tn minus k, Tn minus k minus 1, and the second last term is n minus k minus 2. Okay? Alright, so we know that our base case is, so in this case, you're using 0, you're not using 1. Okay, it's fine. You can use that as well. Okay? And then you're going to put k into 5. Oh, this is 5. Okay. So you get, this one is 2 squared, 1 squared, and this one would be 0. Okay. And this one is a GP, right? This is a, sum of squares, right? Sum of squares, whereby these are the formula. So since the highest order term here is n cube, therefore the running time complexity for this recurrence relation is order of n cube. Anybody got a different answer? Or anybody got have something different somewhere in the workings class? Let me see the chat.
I got the same answer.
Okay, you get the same answer. How about the workings?
Yep. Pretty much.
Doctor, I
Okay.
have a doubt.
Sorry?
I have a doubt.
You have a what? Sorry?
Doubt.
Okay, which one?
When we're repeating this for the n times, or is it k, or is it x? What is it? Can I know?
Okay, so this one we are repeating it for some k times.
Okay, then in the last part of that, so it is supposed to be n minus k minus 2, right?
Okay, you can actually. So if let's say you put here is n minus k,
Okay.
this term, if you put it as n minus k, this one would be n minus k minus 2. This one would be k minus
3.
so yeah. So it depends on how do you put your k Here.
Okay, it depends on how do we take a constant.
Yes.
Okay.
Okay, so
So
you're probably going to get a different, maybe you put here is n minus k, but normally the stopping is here, so your k should be the last term. So it's normally it should be something like this. The last one will be n minus k, and the one will be k minus 1, this one will be k minus 2. So it's
okay.
it's not really like, normally that is what we do. We try to take the k because the stopping would be the, we want to know what is k time, right? So the
Okay.
last term is actually the k.
Okay.
Okay,
We'll have
all
to
right.
put it as K.
Mm. Okay, so sometimes maybe in some workings they put the K, the second last term, because they said the last term is where it will stop, right? But for me, normally I will use the last term as the K. So it doesn't make any difference. It's just that when the running time complexities, normally it won't affect much because it's just some what, because we are looking for the how much is the growth going, okay? So it's just a matter of which point of the graph that you are
Calculating the
including.
running time complexity.
Yeah,
Okay, so you're telling that this constants does not really affect the running time complexity.
constant, we always ignore the constant. We always ignore the
No, no,
constant.
I'm not talking about these constants. I'm talking about this K terms and this stuff.
The key terms, um it's not saying that it is not important, because you still need to consider, because if you put the k properly, mm, I never actually like change it, because I know normally, for because we want to calculate from the how the n goes down to t is equals to 1 or t0. So normally the k, I'll take it as it will be
Bottom.
at the bottom. Yeah.
Okay.
So if
Now I
you,
understand.
just to be safe, you put it as the
K.
last term.
Okay.
Mm.
Thank you.
Okay. All right. Okay. So that is for back substitution. Any more question about this one? No? All good? Okay. This is summation of a square number. Okay. Do you know where we get this? The formula for summation of square number. Yeah.
Progression.
Yeah. All right. So that is for back substitution. Okay. So let's look at B. So for B, we need to do the recursion tree for this relation. Okay. So Tn 2 Tn over 2 plus n squared. Can I have somebody share the answer? Okay, did I mention just now about this one, about the time? About time is supposed, the normally we assume that time is equals to 1, but in this case here is 0. Oh, I did mention. I'm so sorry. I have less lack of sleep last night because my voice is not well, so my brain is a little bit muddled today. Okay, so Tn 2 Tn over 2. Okay, anybody wants to share their tree? No one? I'm waiting. Class? Nobody? Nobody wants to share. Why? You don't know how to do it? Okay. Someone maybe is taking photo and try to upload it. Okay. Just share your answer. Multiple answer is fine too. Whoever wants to share their answer. Okay. All right. So we have one. Ah. Okay, never mind. Yeah, I noticed that how you calculate uh the heights. I saw that the heights is a little bit um I'm not sure how you calculate the heights. But it's fine. Mostly is correct. Okay. All right. So we have one answer here. So what does it mean by this one is that we have this n over 2 branch. Okay. So and this would be the work done at each level. Okay. So level 1 would be n squared. Okay. The thing that is going to be completed is n squared. And there will be two recursive call of n over 2. All right. So n over 2, the n over 2, the n over 2, and then it's going to the work that is going to be done at this level would be n over 2 squared and n over 2 squared. All right. And then you have two recursive call of n over 4 and n over 4. And at this level, the work that is going to be done is n over 4 squared, n over 4 squared. All right. And then again, if you want to go and do the next level of recursion, this one would be t n over 8. And the work done on this level would be n over 8 squared. All right. And then the cost for each of the level would be, this one would be n squared, this one would be n over 2, this one would be n over 4, this one would be n squared over 8. All right. So geometric progression. Yep. So because this one, so normally like for me, I would change it into n over 2 to the power of 0, n over 2 to the power of 1, n 2 power of 2, n 2 power of 3. And then we know that in the end, we will have n squared over 2 to the power of k. Okay, because I think your last term here is not correct. Your last term. Okay. And then do you have a different answer? Okay. So yeah, so in your case, for this answer, this one is supposed to be n squared over 2 to the power of k, not 4 to the power of k. But yeah, it is a geometric progression. If you try to add up, it is a geometric progression. And the answer is I think it's order of n squared. Right? But it's just that for this one, it's supposed to be, the last term would be n squared over 2 to the power of k. Okay. And for the heights, okay, so the heights at this level, T1, the heights is actually n squared over 2 to the power of k. Okay, it's not n squared over 4 to the power of k, because you look at how does the n changes for the Tn. You are not looking at the cost of the work done at each level. We are looking at the value of n, how the n is moving towards the base case. Okay, so the height would be n squared over 2 to the power of k. So are you sure it's n squared? I don't think it's n squared. It's n to the power of k, the heights. So basically the heights will be log n base 2. Okay. So maybe we look at the second answer here. Okay. So whereby we have n squared. So n squared. Yeah, this is what I mean. So normally for me, I prefer to put it this way so that I can see that this is some, you know, that there's a geometric progression later on that I can apply. Okay. And then for the height, why did you get this one? The height is supposed to be, because if you look here, okay, I think the reason why you cannot see this is because you straight away put what is the total work done. Okay, so let me try to share my screen. Where is my thing? I don't know whether what, because my working is always quite messy. Um, wait. Okay, so let me stop this first and try to share from my iPad and see. All right. So this is what I mean by the height is actually based on the one inside. Okay, so if you notice, okay, when you're at this, normally this is level 0, this is level 1, this is level 2, and so on and so forth. So at level 0, so when you break it, it became, when you call the recursive call, you will be sending in T(n over 2, T(n over 2). Okay, in the end, at this level, the work that is going to be completed would be n squared over 4 and n squared over 4. But the n is n over 2. And then it goes down next. So this one will become Pn over 4. And once it's completed, the work that is completed at this level will be n over 16 and 16 and 16 and squared 16 and squared 16. Okay? And then next one is Tn over 8. Alright? And so on and so forth. That will go down until T is equals to 1. So what is this one? So it is actually T and 2 to the power of K. Alright? So the height would be log n base 2. Do you get it? Do you get what I mean? Are you alright? So for the two of you that give me this answer, so the height is actually not n squared 2k. It's for the height of this one. Okay, k log n. Sorry, log n base 2. Alright? Is that alright? Yeah. So once we get the k, and then we can plug it into here, because we know that is the time that this thing is being being called, okay, towards the base case. Are you all alright? Are you guys okay? Anybody have a different answer than this? That is not using n squared over 2k, 2 to the power of k. Any question? Anything that you want to ask? Okay, and then after that, in this case, I don't know where you get the this one. Okay, for the first one, I see that you did. So let me stop this one. So I need to go back and forth between my iPad and my PC. So for, am I showing this one? Okay, so for this one, okay, at least you did manage to get some kind of geometric progression. And yeah, the ratio is 1 over 2. And if you plug in into the GP, you will get order of n squared. Okay. And for the second answer, I'm not so sure how you get to the order of n squared. This one. So for if maybe you can type in or explain to me how do you get this answer. And for those of you who have the same answer as this, please let me know how do you get to that answer. Like for this, I know you get this from this one, which is you're supposed to get this from here, from your how your n is approaching the base case. Okay, and then once you get the k, you plug it inside here, so that you know what is the total summation from the beginning until the end. Okay, so for those of you who have the same answer, can you explain to me, or maybe type in something so that maybe I can point out where did you go wrong, class? Anybody got the proper answer for this one? Where the height is log n base 2, log n. Anybody got the right answer for this? Not right. You still get order of n squared somehow. And the first one is also managed to get order of n squared. It's just that how you calculate your height and the cost is something that you need to correct a little bit in this case. Anybody got the answer that uses the one properly?
I didn't
Are
get.
you? You didn't get what? Sorry.
I didn't get the right answer, so
You didn't get the right answer as well. So, where did you do, like? Is it the same answer like this one, or different? Yeah.
it was the same answer as the color. Yeah, the colored
This
recursive.
one, the second one. So basically, your t is n squared over 2 to the power of k.
Yeah.
Okay. So now, do you know how to get this one?
Yes.
Okay. All right. Okay. So try to fix it. How about the rest? I know it's after lunch. Sometimes after you get lunch, your eyes would be like, especially if you get a very nice lunch. I did a very quick lunch just now, since my boy is not well. So
I hope your son is doing okay. Wait, I just want to clarify one more thing. So as we go down the tree, that means that the t will turn into t bracket 1, right?
Yeah,
And
the base case.
the levels will be going down until n squared over 2 to the power of k times, right?
Yeah.
Okay.
And then you will find what does it mean by k. So the value of k. So you know that would be the how deep is your tree, the height of your tree. All right. And then if you plug in into the equation, so the last equation will be n squared over 2 to the power of k, right? For your cost of all the level. So then you can plug in the k is log n, and then you can use the GP to solve and find what is the highest order term.
Okay.
For those of you who managed to change the answer to that one, maybe you can share just for your record, so that later on when you go back and see this, you have the right answer. Okay. The previous class sort of like screenshot my answer from the screen and put it back inside this one, which they are very clever. So I was like, hey, that is my answer inside there. That is cheating in a sense, but yeah, it's fine. Okay, but for those of you who get who manage to complete the answer, please share it here, okay, so that you can refer to it later.
Doctor, I have one more thing to clarify. In your working, you put t of 1 is equal to t n over 2 to the power of k. So I want to ask, why is it not n squared over 2 to the power of k? Is it because you follow the original equation?
Yeah, because when you pass down the n, it's not n squared. It's n over something, n over 2,
Yeah.
right?
Okay.
Right. So it definitely cannot go into n squared unless the thing when you pass into your recursion, the n is n squared.
Right. Okay. So the levels are just considered n squared.
The level? What do you mean the level? Sorry.
Right. So on the right side of the recursion tree, there's like n squared.
N squared over 2 to the power of k. That would be the last at level T1. So the cost of the work that is going to be done at the last level would be n squared over 2 to the power of k.
Okay, got it.
So it's two different things. You have the height and you also have the cost of what are the total costs for the last level leaf. All the leaf at the last level, what is the what is the cost for that last level? So the n squared over 2 to the power of k is actually the cost of all work that is being done at the last level.
Okay.
Okay.
Yeah.
All right. Any more questions regarding this? How about the rest? Oh my god, everybody is so quiet. On Tuesday, I did one class for 2 hours, and I think I'm talking on my own. I don't know whether they get my lecture or not, because right after our class, I have 2 hours lecture on. I think I was doing it for mobility, so I was teaching like some framework. So I don't know whether they get it or what. So because everybody was so quiet, so for the 2 hours, I don't know whether they understand or not. Okay. Yeah. So please, if you have any question, like please ask. Okay. All right. So that is for question B1. Let's look at B2. Okay. So B2, the recursive relation is Tn equals to Tn over 3 plus T2n over 3 plus n, okay, where n is bigger than 1. So basically the base case is T1 is equals to 1. We can assume that. All right. Yeah, so anybody wants to share the tree? So before that, how do you think this tree is going to look like? Class? You see there, like all our question before, we have 2t and then they break the same equal part. But in this case, it looks like the parts are not equal. The parts are not equal. When you call the recursive call is not equal. So how do you think the tree is going to look like?
I think it will be the left leaf will be n over 3, and then the right leaf will be 2n over 3, and it will continue the same pattern. So even for the second note, the left for the second note also will be n over 3, and then the right for the left note also will be 2n over 3.
Okay, how would you summarize, or how would you describe the tree in general? So if you draw the whole tree, how is the tree is going to look like?
It's the same like before, split into 2.
It will split into 2, of course, because the recursive, there will be 2 recursive call, right? One is n over 3, but and the other one is 2n over 3. But how about try to describe in terms of the number of leaves at each level? Will it be the same? Because like for the one here, for the previous question, or the question that we have attempted before to draw the leaves, to draw the tree, you know that it will stop at T1, and you know that will be the last level, right? So for this question, what can you say about the last level of your tree?
I think the last level, the most left will be the least value, and the most right will be the highest value.
A value in terms of what?
In terms of complexity, I guess.
Maybe what you're trying to say is that the height, is it? The height of the tree?
Yes.
Okay. All right. So basically you can see that this recurrence relation will result into an unbalanced tree. Okay. The one on the left is probably going to be shorter. The one on the right will probably go longer, right? So okay. So with that, how do you how are you going? How does the tree look like? I mean, how do we solve this? Can I see the tree? Anybody can share me one tree? It doesn't matter. It doesn't have to be correct. You know, like you see the previous one, you know that there's a possibility that you know, we confuse certain things with certain, you know, like with some other things. So if we can see what's wrong with the wrong answer, at least you know, like basically you can actually understand more, you know, by learning from the error that you do. Okay, can I see one? It doesn't have to be correct. We can always discuss and revise our answer. Okay. All right. How about this is not the end, right? This is the tree. Okay. Just the tree. Okay. Thank you. All right. So how about the rest of the thing? Okay. Excuse me. Okay. Okay. Nah, mine is even messier. You should see mine. That's why whenever I have to draw a tree, I was like, I hope I hope you are not going to get headache from my handwriting. Okay, so the three are both are the same. Okay, n over 3 to n. This is for n9 to n. It's just that for the second answer, the one on the paper, it's better for you to like complete the third level, because at least we are going to confirm that on the third level we will get the n as well. Okay, just like the first one, whereby we can see that from the first one, when it goes down, it will break into n over 3 to n over 3, and the work done at this level is the same, because this is only n. So we have n over 3 to n over 3. So for n over 3, when it break into the two branch, it will go into n over 9, 2n over 9. For 2n over 3, it will break into 2n over 9 and 4n over 9. Okay. So up until this point, do you have anything, do you know how do we get n over 9 to n over 9 to n over 9 and 4 over 9 here?
Yes.
Yes.
Yeah? Okay. All right, good. So same goes if we continue, we will get n over 27, n over 2n over 27. And here, we have 2n27, 4n over 27. This one will be 2n over 27, 4n over 37. This will be 4n over 37, and this will be 8n over 27. Okay, so the tree should look like this. All right, and then we're going to calculate what is the cost for each of the level, and we get that for each of the level, the amount of work that is being done is n. Okay. All right. So okay, since this one is only the 3, this one is a 3 as well. But I would suggest you have this so that we can confirm the third level as well. So let me try to zoom in a little bit on this. Okay. All right. So what is the height of the tree? The height of the tree would be, I think this is the same the same mistake like the one that we did previously, because in this case you are taking wait, 2 to the power of k and 2k, and why are you saying it's k? Okay, so okay, let me try and okay, so which leaf that you think will which, how do you call that, which branch that you think that will go like really long? It would be from this one, right? And 2n3, 4n9, 4n9, 8n27, right? So basically the longest tree would be this path. And you know that the longest tree would be those coming from the rightmost branch, okay, from the top. So the height of the tree will be based on the longest branch in the tree. So let's try and see how is the n changes for each of the level. Okay, so how does it change? How is it change? How is it changing? So it's changing, sorry. So we have 2n over 3, and then going to 2 power of 1. Okay, so maybe I will share you my why do you have n here? N power of kn. Why do you have n there? Okay, 2n to the power of k. 2k to the power of n. Okay. So what is the k? What is the k? Oh, here.
Okay, I think it's the height.
Yeah, on the side. Yeah. I was looking for this one. I didn't see this one. Okay. So 2 to the power of k and 2 to the power of k is equals to 1. Yeah. Okay. All right. Yeah. Okay. Okay. So therefore, your k is 3 log n 3 over 2. Okay. Yeah. So I think this one is correct because I see this 2n. And 2 and then both of the what is actually to the power of k. Okay, so you get k log n 3 base 3 over 2. Okay, and since we know that, so now we need to calculate the sum of all work that is being done at each of the level for some k times. So therefore, we times n times the height of the tree. So therefore, we get this answer. Alright. So anybody don't get how do you get this answer?
Doctor, I have a question.
Yes.
So for this case of tree, which is this is the uneven tree, right? So the branches is not equal. So in this case, for the last term, which is T1, we should take the biggest value, or how do we manage to get the formalized T1? Because if like the previous question, so the branch is all the same, right? So we can easily do the T1 formula, like before is n over 2 power of k, right? So but this one is the child is different. So how do we want to confirm the formula?
Okay. So for the height of the tree, okay, so for each of the branch, maybe perhaps where it's how high the tree grows for each of the branch may be different, but each last last node of the tree will stop at T1. Do you get what I mean? So even if like the the leftmost maybe like this short, but the end term it will still stop at T1. For the intermediate branch, it will still stop at T1. Same goes for the longest one. The last node will still stop at T1. It's just that how it is approaching T1 is at a different rate, because of one of it is like n over 3, 1 over 3. Okay, you only like increase it to 1 over 3, 1 over 3, 1 over 3. And the other one is 2 over 3, 2 over 3, 2 over 3. So the what will be longer. So it will be slower to approach the base case. But all of the leaves is going to stop at T1. It's just that we are taking the longest because that would be the one that will complete the whole recursive call. Do you get what I mean?
Oh, so it's like we're taking the worst case, something like that?
It's not the worst case, but you know, like when you run a recursive function,
Okay.
of course you want it to complete, right? So the
Yeah.
complete will be will be the last. Even though the
Oh,
run
okay, I
is
get it
finished.
now.
Yeah, yeah.
Okay.
So it's not really the worst case. It's
It's
more
like
like you.
it's like when the slowest is finished, so we can confirm that all is finished.
Yeah,
Okay, I get it.
yeah.
Okay, thank you, doctor.
All right. Okay. Any more question for this one? Yes? No? Okay. All right. So that is for recursion 3. Okay. All right. Oh, there's another one here. Let me try to zoom up and see. Okay. Oh, okay. So this one, how did you do that? 1 over 3 and 3 over 2. N over 3, 1 over 3, and oh, okay. So you're doing it one by one. Wait, let me see. And 1 over 3 and 2 over 3 and okay. So is it that you're trying to calculate the amount of work? So you put it inside here so that you can see. Okay. So 1 over 9 and 1, 2, 3. 2 n over 9 or n over 9. Okay. But then it's not enough to see how does what is growing. So normally it would be nice to see another level, but in this case you have en 3 to the power of k equals to 1. And the other one is on this side, you have 2 to the power of k and 3k is equals to 1. Okay, so you take the longest one, which is log n 3 over 2. So the height on this side is this one. The height on this side is this one. Okay, so of course you will take the longest one, okay, the slowest one, and then you stop. There's no, so you need to calculate. So for each of this level, you need to calculate the cost and you have to time it with height. Okay, so for those, for whoever that is giving me this answer, so I hope I'm showing you the right page. Okay, so whoever is doing this answer, this is not complete. You only you managed to calculate the height, but you haven't yet calculate what is the total running time for the whole recursion algorithm, for the whole recursion. Okay, all right. Any more question? No? Okay. All right. So normally I won't write it this way because it's going to make it it's going to make it a little bit confusing. So maybe you just cross it and you just leave the cost that you have done there, because the plus might get you confused. Okay. But if it helps you to visualize, then yeah. So I know that you put the plus just to visualize that this is actually for the last n. Okay. All right. Okay. So maybe we can finish our tutorial fast today. Okay. So let's look at the master methods. So let's solve the following recurrences. Okay, so as I mentioned in the lecture, I believe I mentioned it. Okay, sometimes if you look at the master method, there are several ways of how you can, find the values of the values that you need to plug in into the formula. Okay, so for the one that I use, I believe that would be the simplest one because I've tried 3. The first one is the common method. The second one is that the comparison, instead of log a base b with k, I compare it with a and b to the power of k. Okay, but then the formula is still the same. All right, so let's try and do this together. Okay, so for question 2a, what is the value of A? What is the value of B? What is the value of K? And what is the value of P? Class?
A will be 2, B will be 4, K will be 0, P also 0.
Okay, so what is the case?
The case should be case 1 because A is greater than B power of K.
Okay, and then after that, what is the final answer?
So I share the answer.
Yeah.
So the Tn will be n power of half.
Okay, so it would be, yeah, it would be, what is that word again? Square root n. Okay, it's theta square root n. Okay,
Yes.
so who do not get this answer? Everybody can get the same answer? Yes? Okay. One person say yes. How about the rest? Okay?
Yeah, same one.
All right. So question B. What is A? What is B? What is K? What is P? In this case, so A is 2. B is 4. K is 0. No, K is not 0. K is what?
K is half.
Okay. Your friend said that the formula is not clearly in the slide. Are you sure?
Yeah, it's
This
in the slide.
this is the, wait, let me share this one. This is the formula. The formula is this one. This is the formula. Oh. Sorry. This is the formula. Okay. This is the one that I do from try to plug this one in for a bit. Okay. All right. Okay. So for B, A is 2. I'm sharing the right. Okay, so A is 2, B is 4, K is half, P is 0. Okay, so this one would be, so what is the case? So log A base B.
This is case 2, right?
Log A base B. I'm sure it's case 2. We are doing B. Oh, we are doing B. Okay, it's case 2. So if it is case 2, what is the case 2? So if we look at the formula, case 2, we have A, B, and C. So our P is what? P is 0. So case 2A, which one? A, B, or C? So P is 0, so therefore our P is bigger than -1, right? So we take A to A. Yeah. So n to the power of K. So n square root log P plus 1. So log n. Why do you have log n? Log n only. Because it's case A. Okay. All right. Okay, so that is B. How about C? How about C? What is A? What is B? What is K? And what is P? How about the rest? I have like around 30 something, just now 20 something in my group. I should not have like 30 something because I think for group 3 it's supposed to only have 20 something. So yeah, I have 31 in my group. So if you are not supposed to be here, please go to your respected group. Okay, because the lecturer is already complaining, saying that they don't have the student is not in their class and saying that they were somewhere else. Hence the announcement on last Tuesday. Okay, because I couldn't possibly check each of you. All right. Okay, so we are at C, right? Okay, so we have A. So A is 2, B is 4, K is 1, P is 0. So this one is case? This one is case 3.
Yeah.
Yeah. So case 3 is, let's see the formula, is it A or B? So since P is equals to 0, we take case A, 3A, right?
Yeah.
So we're supposed to get n to the power of K log P is 0 n. So it will be log theta of n. Okay. All right. So D. So A is 2, B is 4, K is 2, P is 0, K is 2A. Alright. D theta 1? Really? 4D? K is 2. And n to the power of 2. N squared. 4D. Right? For question D. We'll get a different answer for 4D. Just now someone said it's a constant. Okay, so for E, this one is not complete. So yeah, so maybe you can put it back in. Okay, so why B is 1/2 for question E? Okay, I think so for question E, B is not 1/2. B is 1/2? No. B is 2. Yes. B is 2. Not 1/2. It's the bottom term. The one. If you look at the recurrence form, the B would be the N over B. Okay. That is E N squared. Okay, so case 3A order of N squared. Okay, for F N squared, so for A is 4, B is 2, K is 2, P is 0. So this is case 1. Okay, so case 1, what is the answer? So case 1 would be N log A over B. A base B. What is log 4 base 2? You don't. What is log 4 base 2? It's equals to 2, right? 4 base 2. For F, I'm talking about F. N squared. Okay? N squared, and then it's not complete. The formula said for case 1, are you sure it's case 1, that one? So log A over B is 2, and K is equals to 2. It's supposed to be case 2. For F, everyone, look at question F. Look at question F. So log 4 base 2 is 2. So it's equals to K. So it's case 2. So case 2, since P is 0, so case 2A. So case 2A is N to the power of K. So N squared log P plus 1. So log N. Right? Right. Okay, so for G, this is the question that just now in the morning my brain just go blank. Because I got a different answer. the schema said the schema said that it is theta of 2 to the power of n, but somehow my previous working, I said that we cannot complete this question. So just now I was like trying to study, okay, and see how we can plug this one in to the formula that we do, right? So I managed to find it, though I kind of like need to check, need to double check, but I think that is the way it is supposed to be. Okay, so the n in this case is 2 and the k is n. We assume that n is 2 and the k is n. So we try to keep the form of a recurrence relation. Do you remember the what is the form of a recurrence relation? N is equals to 2. K is n. So, okay, so let me type this one in. So if you remember the recurrence relation, we can say that T n, the form is some A T n n over B n over B plus plus where is it? Plus, where is the formula? So we have Fn. Oh, they call it as Fn. Okay, so n, sorry, this is will be the theta or big O. Okay, O n, and just now control. Oh, what is it just now? Okay, K. Somebody teach me how to do that one just now. And I'm so proud that I know how to do that already. Log to the power of P and N. Okay, so we try to keep to this. No, I do not want to. I don't want this. I want this one to be. Oh, sorry. What is this? Okay, so we try to keep referring to this format. Okay, so that's why we say that for this question G. Okay, so for this question G, we would say that our A is 1, our B is 2, our K is N, our N is 2. Do you get what I mean? Okay, and then after that, we try to P is 0. Our N is 2. We need to say that our N is 2 because we need to plug it into our formula later on for the case, for the formula in the what? P is 0. And our N is 2. Because we want to keep the form. We want to follow the form that is given in order for us to use the master theorem. Yeah. And then after that, do the comparison. So log 1 base 2. What is log 1 base 2? Is 0, right? Log 1 base 2. Maybe I'll try and write it for you. I think that will be easier. 1 second. Let me share this side. So let me share my screen. Where is my... Okay. So this is the form that we want to keep, right? So since this is Fn, so we have, what is our question just now? So it's it's Tn T n over 2 plus 2 to the power of n. And we say our A is 1, our B is 2. In this case, since we want to keep the form in order for us to do the to apply the master method, we can say that our n is equals to 2, our k is equals to n, our p is equals to 0. Okay, so we are going to compare log 1 base 2 with k, right? So log 1 base 2 is equals to 0, and k in this case is n, right? Are you following so far?
Yes.
So in this case, we assume since n is always like either 1, 2, 3, and so on and so forth, because this is exponential. The graph go up. This is an exponential function. So we can say that it is case. What case is this? This is case number
1.
maybe. Sorry, no, it's not case 1. It's case 3. So case 3. So case 3, we can apply this one, right? So the answer should be. So this is case 3 A. Therefore, the T of n is equals to theta so our n is 2 to the power of n log p, so p is 0, n. So therefore, we get the answer as theta 2 to the power of n.
Wait, I'm a bit confused how it's case 3. Could you explain again?
This one, because log, this is our log a base b, and this is our k. So since log a base b is 0 and k is n, so log 1 base 2 is 0. Last I checked with the calculator, the online calculator for logarithm, so we get 0. And we know for the n, the value would be 1, 2, 3, 4, and so on and so forth, because it's an exponential function. So we know that n would be bigger than 0. Definitely it will be bigger than 0. So we can say that this is case number 3. And since p is 0, so we apply case 3a, and therefore we get the answer theta of 2 to the power of n. And in fact, actually, because as you can see, so when we have this kind of recurrence relation, we can take it as this one as fn, and this one as g of n. So we just want to make, basically what we are trying to do is that we want to see whether this fn is upper bounding this gn, or this gn, this recursive function, is upper bounding the fn. So basically that is what we're trying to do. Do you get what I mean?
Oh yeah, makes sense.
Yeah. So in a sense, for this question, we already know that this is already like going to upper bound whatever function that we have on the other side, because this is exponential, right? So yeah, so basically that is what we're trying to do, because we don't know what is the running time complexity for the one that have the recursive call. We don't know how deep or how many, what are the running time that that will be taken by that recursive function. Okay, so when you have basically what you're trying to do is you compare between Gn and the Fn and see which one is upper bounding who. That is what we're trying to do actually in this case. All right. So yeah, so that would be for question G. Excuse me. All right. Okay, so where we are G, now we are going to do H. So I think from here on it's pretty straightforward. All right, so for H, we have A as 16, B as 4, K as 1, P is 0. So it is case 1. And the answer is n squared. Okay, so A, B, B, that is 4, so that's case 1. So, okay, all right. So for I, 2t n over 2 n log n. Okay, so A is equals to 2, B is equals to 2, K is equals 1 is case 2. P is equals to 1. So if P is equals to 1, so case 2 what? Case 2 A. So n to the power of k, kn log P plus 1. So P log square log 2 square log squared n. Okay, is it the same if we put like that? Log squared n. I think it should be the same. Log squared. I seriously don't remember much, but I don't remember my logarithm rules. I need to refer back. So when you give me like this, so can you check, is it still the same like log squared n?
Yeah, it should be the same.
Yeah. Okay. So it's supposed so it's log squared n or log log n squared. Okay. All right. Okay. So in that case, any more questions?
Doctor, I have one question for the question 2G. Okay, so we know that K is equal to N, right? So how do we know N is how do we know 0 is less than N? Because is it N can be 0 as well? Or cannot?
Do you remember that whenever we want to do the analysis, n cannot be 0, n must be more than 0?
Oh yeah, okay.
Yes.
Okay, thank you.
Okay. All right. Okay, any more question? No? Yes? Okay, upload 1B2. So question 1B2. What is question 1B2? 1B. Oh, this one. For this one. This one is fine. I have the same working as this one. 1B2. If you're talking about the one, right? So this is fine. The answer here is fine. 1B2. You're talking about this 3, right? It's just that I would suggest for the third level, you still fill up the value. Okay? Yeah. All right. So yeah. Oh yeah. Says to form the group. I seriously totally forgot that I need to give you the Excel form so that you can register your members. Okay, so please make sure that since this is supposed to only be group 3, so you can only form a group within your within group 3. Okay, for those of you who know each other and already have a group of 5 to 6 people, you can register your member. And for those of you who have no group or only have like 2 or 3 people, maybe you have a pair, you just put in your name. So it's either later on I will combine you or I'll add other members inside there. So just put in your name. So if you don't have any group, you just put in your name that you don't have any group. And if you can only find 3, then you just put the 3 of you, the name of the 3 of you, and then you can see inside there. You can also see people that do not have a group. So you can either contact whether you want to contact the group or the group wants to contact the individual. So normally if you are individual, you will try to contact the group, see whether you can join their group or not. Okay, is that okay? So to form the groups, I will share you the Google sheet for registering your member. I will try to do it by tomorrow. So and then I will share the link with you on Telegram as well as in the Spectrum. Okay, and maybe I'll post it here as well. All right. Any more questions? Did I miss anything on the chat? No, right? Okay, so again, please make sure you mark your attendance. And then if you're not supposed to be in this group, please go to your assigned group, okay? Okay, so if there is if there's no more question, okay, so we finish a little bit early today, so it's good. All right. So if you don't have any question, then I will see you next week. Whereby I think we're gonna be looking at sorting topic. Yeah. Okay. So we're going to start looking at the interesting algorithm, and I believe it's going to catch your interest, because then usually you look at programs and you don't know like what are the things other than what are the output that you can get out of that algorithm. But basically in this course, you should be able to see, like somehow I can improve the performance of the algorithm if, like, let's say I took it this way, if I took it that way. So yeah, especially for those of you who likes to join the programming contest. So yeah, so this is something that might interest you a lot. Okay. All right. So yeah, so if we have nothing else, no question, then we end the class for today. Is that all right? Okay.
Yes, Doctor.
Okay. So for this one, again, the answer for B1, please update. Okay, for those of you, for whoever that get the answer already. Okay. Please update, and then I think that's it. Okay. All right. So in that case, I'll see you next week, everyone. Thank you. Bye.
Thank you, Dr.
Assalamualaikum.
Thank you,
Thank you,
Doctor.
Doctor.
Salam.
Bye.
Salam. Thank you, Doctor.
Thank you.